Hello friends, in this video we shall discuss with respect to AE paper of instrumentation which is conducted by KPCL on 18 February 2024. The total number of questions were 100 in number, marks allotted is also for 100, negative marking is there. In this part 1 video we shall discuss from question number 1 to question number 50. The JEE and AE paper of electricals already been uploaded on my channel. If you are interested you can refer to it. If you want the Kannada version of it, I will be providing the links in the description. You can please go through it. To my effort, I expect only 1 like from you. In the first question, what they have given is, which of the following mode of the signal is bidirectional, they are asking. See, this question is from HDL. In the HDL, we have to talk about VHDL and Verilog. In the case of Verilog, how you are going to define input and output means you are going to define it as INPUT and OUT PUT, input and output. But in the case of VHDL, the scenario is different. For the input you are going to define it as IN, and for the output you are going to define it as OUT. For the node or the port to be declared as input as well as output, you are going to define it as in out. You are going to define it as in out. So the corresponding option that is going to follow is option C is correct. So this question is from VHDL. Second question, the statement in between the keywords that is going to enclose between a begin and end are called as a dash, concurrent statements, netlist, declaration statement and entity function. So even this question is also from HDL. So that's been enclosed between begin and end in concurrent statement. Third question what they have given is the operator and is referred to. It is referred as what? Concatenation operator. If I am writing a double ampersand, then it is referred as logical AND operation. Option D is going to follow. Fourth question, see, the Intel 8086 microprocessor is how many bit processor they are asking. Don't get confused and don't opt for something like 20 or some other option. It is a 16-bit processor. But if I am speaking with respect to address lines, so it is a 20-bit wide. And if I am speaking with respect to microprocessor 8085, so it is a 8-bit processor. And even if I am speaking with respect to microcontroller 8051, it is 8-bit. 8086 is a 16-bit processor. Fifth question, see what they are asking is the microprocessor is performing read and write operation which is of 16-bit data. So this read and write operation is into memory, input output device, processor and register. Now look at the things. You consider this one to be CPU and this is your memory. Now what you are going to do is you want to store the information. You are going to perform write operation. You are going to retrieve the information. Then you are going to perform read operation. So these things are achieved with the help of memory only. So we are going to make use of address bus and data bus in order to fetch the particular memory location, and in order to transfer the data we are going to make use of data bus. So the corresponding option that is going to follow is option A is correct. Sixth question, in the case of 8086 microprocessor, the address bus is of how many bit wide they are asking. See, in the case of microprocessor 8085 and in the case of microcontroller 8051, so in these two cases the address bus is of 16-bit wide. The address bus is of 16-bit wide. But in the case of 8086 microprocessor, the general purpose register and many other registers are of 16-bit wide only, and in the segment register is also 16-bit wide. Now the question is how we are going to generate this 20-bit wide. Nothing but how physical address is calculated. So in the case of 8086, physical address is calculated with the help of segment registers. So we will be having 4 segments. One is data segment, code segment, stack segment and extra segment. So here what you are going to do is you are going to make use of segment register address or the pointing value into 10H or 16 in decimal, plus you are going to make use of offset register You're going to make use of offset register, SI, DI, BP, something like this you are going to make use, and we are going to extend it to 20 bit wide. We are going to extend it to 20 bit wide. Option D is going to follow. Seventh question, in which year 8086 was introduced? So 8086 was introduced in the year 1978. It is the advanced version of 8085 microprocessor. Ninth question is from CMOS. In the case of MOS transistor, dash is used for the gate, or dash will be acting like a gate terminal. So we are going to make use of polysilicon. Option C is going to follow. So you will be having the channel, on top of it you will be having the dielectric, or you can call it as a thin oxide. On top of it you are going to lay a polysilicon, so which will be acting like a gate terminal. Option C is going to follow. Ninth question, source in the case of MOS transistor is doped with. See, in the case of NMOS, the source terminal and the drain terminal is made up of N type. And in the case of PMOS, the source and drain terminal is made up of P type. Right? Now, if I am speaking with respect to the gate terminal, the gate is made up of, in both the cases we are going to make use of polysilicon only. Polysilicon only. Right? Now, if I am speaking with respect to NMOS, if I am speaking with respect to only NMOS logic, so all the pull-up network will be replaced by either depletion mode or enhancement mode NMOS transistor. So at that time source and drain is made up of N type only. If you are making use of both NMOS and PMOS, then it is a CMOS logic. So they are referring to this part. In the case of NMOS, we are going to make use of N type for source and drain. In the case of CMOS, we are going to make use of N and P type. 10th question, depletion mode MOSFET are commonly used as what? Now look at the things. In the case of depletion mode, what you are going to do is, in the case of CMOS logic, the pull-up network will be having a resistance of 2.5 times of RS. And the pull-up network will be having a resistance of RS. And here the load will be 2 square Cg. Here the load will be 2 square Cg. Right? When the pull-up network is on, the delay will be R times of C, which will be 5 times of tau. RS multiplied by Cg, square Cg is referred as a tau. It is 5 tau plus. On the discharging one, it is RS times of 2 square Cg. So it is 2 tau. Strictly speaking, this one we are going to make use of two similar CMOS logic, and then we have to derive the delay. But in the case of NMOS, we will be having the pull-up network will be having a resistance as 4 RS, and the pull down will be having a resistance of just RS. The load will be 1 square Cg. The load will be 1 square Cg, because only one capacitance need to be driven. But in the case of CMOS, 2 capacitors should be driven. Right? So pull up 4 tau, pull down 1 tau, so which is 5 tau. Right? So these things are representing a resistors. Option B is going to follow. 11th question, see, you will be having or you will be writing schematic first, then stick diagram, then later on you are getting into layout. Layout means what? Actual distance, each and everything we are going to specify properly. The stick diagram is something like a cartoon kind of thing. So in this stick diagram are those which convey layer information through. So it is going to provide information based on colors. Option B is going to follow. Color coding, we have to remember which color is used for N diffusion. In the case of N diffusion, we are going to make use of green color. That is option C is going to follow. In the case of metals, we are going to make use of blue color. And again, polysilicon color we should know, via color you have to know, contact cut color you have to know, each and everything are important. So they have given good weightage for CMOS VLSI subject. The incorrect for an operational amplifier is, The incorrect option they are asking, it has high voltage gain. Yes, the op amp will be having high voltage gain. Since they are asking for the incorrect option, option A is wrong. It is direct coupled amplifier. Yes, it is a direct coupled amplifier. It is only used for amplifying AC signals. So this question is an inappropriate one, right? Option C is going to follow. It was originally defined or designed for mathematical operations. Yes, you can perform logical operation, anti-logarithmic operations, and differential. All these things can be performed, right? 14th question, for the ideal op amp, the false statement is open loop voltage gain is infinity, input resistance is infinity, slew rate is infinite, CMRR is 0. They are asking. CMRR is infinite. Since they are asking for incorrect statement or the false statement, option D is going to follow. 15th question is based on oscillators. See, we have studied with respect to 5 variants of oscillators. One is Hartley oscillator, and the second one is Colpitt's oscillator, and the third one is RC phase shift oscillator, and the fourth variant is Weinbridge oscillator. Now, what is the formula for frequency in all this scenario? See, in the case of Hartley oscillator, we can define F equals to 1 divided by 2 pi times of root LC, where L equals to L1 plus L2. That's it. L equals to L1 plus L2, and C equals to C only. In the case of Colpitt's oscillator, F, nothing but frequency, is defined as 1 divided by 2 pi times of root LC, where L equals to L and C equivalent is defined as C1 times of C2 divided by C1 plus C2. C1 plus C2. But in the case of RC phase shift oscillator, it is defined as 0.065 times of R divided by RC, right? In the case of Weinbridge oscillator, it is defined as 1 divided by 2 pi times of root of. So, you will be having two resistance R1, R2, and you will be having two capacitance, right? In an op amp based configuration, you are going to connect. If say suppose if R1 equals to R2, if it is equals to R, and if C1 equals to C2, which is equals to C. So, the frequency of oscillation F equals to 1 divided by 2 pi RC. Option C is going to follow. The features of instrumentation amplifier is 16th question. What they have given is the features of instrumentation amplifier. So, the options what they have given is low noise, high gain accuracy, low thermal and time drift. Even input impedance is also high, so you can go for all of the above option. So, option D is going to follow. It is having a low noise, high gain accuracy will be there, low thermal and time drift is also there. 17th question onwards, the questions are from C++. The encapsulation in the case of hoops is a way of combining various. So, you can go to the option. So, data members and member function that operate on those data members into a single unit. So, option A is correct. 18th question, data elements in the case of C++ structure are also known as objects, members, data and objects. So, it is referred as members. Option B is correct. The role of a constructor in the case of classes. So, when you are going to create a class, the constructors are automatically created. At the termination, destructors need to be created. So, the role of a constructor in the case of classes is to initialize the data members of an object when it is created. When it is created, option C is going to follow. So, this question you see, the operator that cannot be overloaded in the case of C++ is referred as. Now, I can write this B option as, see, say suppose if I want to write the if statements, if I want to write the if statement, if of say suppose A greater than B, then I have to execute the statement C equals to A, else C equals to B. If you want to make use of flower bases, you can use, or else you can skip it. Now, how can I write this one? It is A greater than B question mark. Then if part need to be executed, then else part need to be executed. Else part need to be executed. Option B is going to follow. And next question is based on pipelining. This question is applicable even in microprocessor 8086 as well as in DSP processors also. So here what they are asking is, pipelining is the one which improves the performance. See, when one instruction is being fetched, the previous instruction is being decoded. That previous instructions can be executed. All these things are done simultaneously. So this is used for parallel processing of instructions. Option A is going to follow. 22nd question, you see, in the case of DSP processor, MAC dedicated unit block will be there. So it is referred as what? Multiply and accumulate unit. So here we are going to make use for signed and unsigned multiplication. One is you will be having Booth multiplier, and the second one you will be having Bahuli multiplier. It is not Bahubali multiplier, it is Bahuli multiplier. So one is used for unsigned multiplication and the second one is used for signed multiplication. Signed multiplication. Option B is going to follow. The bit reversal often performed in Fourier transforms or fast Fourier transform algorithm on DSP processor is referred as. See, in the case of DIT FFT and DIF FFT, you are going to make use like this. Input is time reversal, output is in the normal form, or input is in the normal form, output is time reversal. What exactly you mean by time reversal means, let me consider three data for understanding purpose. Now what we are going to do is, in the case of bit reversal, first bit and last bit we are going to interchange. So when we interchange, you are going to get the value something like this. 1 will be here, 0 will be here. And for 0 1 0 it will be 0 1 0 only. Say suppose if I am taking 0 1 1, so first and last bit need to be interchanged, middle bit is retained as it is. So here the sequence is 0 1 2 3, but what is the sequence over here? 0 4 2 6. So this is bit reversal form. This is used to perform or to facilitate efficient data access. Option D is going to follow. 24th question, you see, the direct memory access is used to perform or is used to reduce power consumption, allows for faster memory access, eliminates the need for memory, enhances the accuracy of computation. So reduces the power consumption is wrong. Why we are going to make use of DMI means for faster memory access. Option B is going to follow. Option B is going to follow. 25th question, again it's a direct question what they have asked. The SI unit of force is a Newton. The SI unit of force is Newton. Right? 26th question, ultrasonic proximity sound frequency range. What is the range for this ultrasonic sound frequency they are asking? So it is 25 to 50 kilohertz. Option C is going to follow. 27th question is based on LEDs. So here you will be having population inversion concept. So you are going to create a metastable state. So this is the higher energy level and this is the lower energy level, right? Between the two you will be having something like metastable state. The stable state is the lower one, the unstable state is the upper one. But for a time being or for a small duration, the charges will be, or the electrons, the charges will be lying on metastable state for some duration. So it is which state they are asking? E2. 28th question, the common material used for the junction of a type K thermocouple is copper constant. Option A is going to follow. 29th question, you see what they are asking is, in the context of radiation, an idealized surface that absorbs all incident radiation is referred as what? Black body. Black body is the one which will be absorbing all the radiations. 30th question is based on aliasing. See, say suppose if the sampling frequency is greater than the twice the highest component frequency of the message signal, then it is referred as what? Oversampling. Then it is referred as what? Oversampling. If say suppose the sampling frequency I have chosen in such a way that it is equals to twice the highest frequency component of message signal, then it is referred as what? Nyquist sampling. Then it is referred as what? Nyquist sampling. Say suppose if I am choosing the sampling frequency such that if it is less than twice the highest frequency component of the message signal, then it is referred as what? Undersampling. Undersampling. So here you will be getting the effect that is referred as what? Aliasing effect. Aliasing effect. So the highest frequency component is 5 kilohertz. Greater than 10 kilohertz or equal to 10 kilohertz you should get. Then that one is the valid sampling frequency. So option D, that is 5 kilohertz is the invalid sampling frequency. Option D is correct. 31st question, a proportional controller will have an offset difference between the set point and the control point that will eventually vanish. That will eventually vanish. 32nd question, the function of the integral reset mode is used to. It is to eliminate the offset. Option C is correct. So straight away direct questions they are asking. So no need to explain all the options. For proper feedback in the process control element, it is required to measure P, measure set point, measure error, measure the comparator they are asking. So it is used to measure P point. Option A is going to follow. Which are the following are the components of process automation? For process automation, we are in need of the sensors, controllers, actuators, and all the things are required for the same. So option D is going to follow. Programmable logic controller operates on the following signal: digital, impulse, analog, and frequency. So it operates on the digital signal. Option A is going to follow. Thirty-sixth question, what they are asking is, in a PLC, which of the following is not a subpart of CPU? Microprocessor will be there, memory will be there, power supply will be there, but the programming part will not be there. So option A is correct. SCADA stands for, see, for automation we are going to make use of SCADA. So this SCADA stands for Supervisory Control and Data Acquisition System. Option B is correct. Thirty-eighth question, fuzzy logic is a form of. So options what they are given is two valued logic, crisp set logic, many valued logic, and binary set logic. So it is a many valued logic. What is used to determine the nature of the learning program? So we want to learn from the mistakes what we have done, or we have to correct those mistakes. So for that we are in need of a feedback. So the system is in need of a feedback. Option A is correct. 40th question, you see what they are asking is, in which type of neural network the data is grouped based on its distance from a center point? So it is with respect to radial basis functions neural network. Option D is correct. Now this question is from transducers. So if you are in a position to justify what do you mean by transducer and the types of transducer, that is more than enough in order to solve this problem. So the transducer which needs an external power supply for its operation is referred as a passive transducer. Which does not require an external power supply, it is referred as an active transducer. A transducer is the one which is going to convert a non-electrical signal to electrical signal. That's it. And in the process of conversion, if you are going to make use of resistors, then it is a resistive transducer. If you are making use of an inductive network, then it is referred as inductive transducer. If you are making use of capacitors network, then it is referred as capacitive transducer. So all these things I have explained in the revision part of electrical transducers. If you have not gone through the video, links are given in the description. Also, you can click on the I button. Option B is going to follow. 42nd question, you see bonding element in a strain gauge must have. So the options what they are given is zero insulation resistance, low insulation resistance, high insulation resistance, infinite insulation resistance. We are in need of high insulation resistance. Option C is going to follow. Even infinite is also not preferred, right? So far we have discussed 42nd question. Yet another 8 questions are there. If you can able to understand with the solution video, I expect only 1 like from you. So now onwards we can slightly focus on the problematic questions also. 43rd question, if D1 and D2 diodes are ideal one, then the value of the current through D2 is. Now look at the things. Among D1 and D2, which is a forward bias or which one is conducting? The anode terminal of D1 is connected to positive side of the source, current source. Here in the case of D2, the anode 1 is connected to negative. So I can tell D2 as of now it is in off state, D1 is in the on state. Now I have to prove that the current that is flowing through D1 is greater than 0, right? So I will be assuming that the D1 is an ideal one. So greater than 0 volts is more than enough in order to conduct. Now the entire current will be flowing through D1, hardly few milli or microamperes of the current will be flowing through 2 kilo ohms, so which is neglected. Now you will be having 2 paths. One path is through diode D2 and the second path is through this 2 kilo ohms. Now look at the things. High milliampere is the current source. Now there will be a voltage drop across this 2 kilo ohms, then that voltage, let me take it as Vx. So there will be a voltage drop across this 2 kilo ohms, positive side is over here, negative side is over here. That means what? D2 is in a off state, that we have proved. So in the off state, what is the current? Current is roughly equals to 0 milliamperes or 0 amperes, right? Strictly speaking, the current is in the order of microamperes, but all the options is in the milli. So I am going to opt for the first option, that is 0 milliamperes. The power amplifier output used for less than 180 degree operations is, we are going to make use of class C amplifier. Already I have discussed class A what is the conduction cycle, class B what is the conduction cycle, class C and class AB, class D also I have taught you. 45th question is based on digital electronics and they are asking us to realize the mod 16 counter. Say suppose if I am applying the clock pulses, I have applied the clock pulses for 37 times, and then what is the output? Initially what they are asking is the initial output is 0110. Since it is a 4-bit wide, so after 16 clock pulses it is going to read the same value. After 32 clock pulses also it is going to read the same value. After 48 also it is going to read the same value. Now, so I have finished with the 16 counts. After 16 counts also it is going to read the same value. After total 32 counts also it is reading the same value, nothing but 0110. In 33rd count, what is the value it is reading? It is a down counter. 0110 is 6. 5 means 0101. And in the 34th cycle, it is going to read 0100. And in the 33rd cycle, it is going to read, clocks should be incremented, right? Sorry, I made a mistake. 34. And in the 35th clock cycle, it is going to read the value 0011. And in 36th clock pulse, it is going to read the value 0010. And in 37th clock pulse, it is going to read the value 0001. Nothing but the value is 1 in hexadecimal or decimal, you can think. So option that is going to follow is option B is correct. They can ask the question something like, after 1 lakh cycles what is the output, after 2 lakh, after 10 lakh. So simply to confuse, they can create these kind of numbers. But if you are knowing the mod, that is more than enough in order to realize these kind of questions. Option B is going to follow. 46th question, again simple question they have asked. The maximum frequency of operation of an inverter with a lower to higher, which is 7.9 nanoseconds, high to low it is 4.9 nanoseconds. The total time period T, which is written as a low to high plus T high to low. What is the value they have given? 7.9 nanoseconds plus 4.5 nanoseconds. This is the value of T, nothing but time period. Frequency is defined as 1 divided by time period, which is how much you are going to get, means 80.64 megahertz. Option B is going to follow. In 47th question, what they are asking is the value of the current in 20 ohm resistor is given by. Now here you will be having two principal nodes. One of the principal node need to be connected to lowest potential. Another principal node, this nodal voltage I am going to take it as Vx. I am going to assume all the currents are leaving and then I am going to solve. So when you are writing the first step of the voltage equation or the nodal equation, you can eliminate two options. Now you please consider all the resistance are in ohms, then the current will be in the amperes only. If the resistor value is in the kilo ohms, then the current will be in the order of milliamperes. So for the problems what we have solved. So here they have given 8 milli, so I am going to take it as 8 amperes and then I am going to solve. Without taking 8 amperes, if I am taking 8 milliamperes, then the option will be different. Then the answer will be different for you. So what I am going to do is, I am going to take this 8 milli as 8 amperes and then I am going to solve. So the outward current is, so this left one, it is a minus 8 amperes. So the left one is in opposite direction, so it is minus 8 plus this, the current through 10 ohm resistor, that is Vx minus 0 divided by 10 plus Vx divided by 20 plus Vx divided by 30. The current direction and the current that is flowing is in the same path only. So I am going to take it as plus 20 plus Vx divided by 60, which is equals to 0. Now I have written the nodal equation in order to get the value of Vx. Now look at the things, minus 8 plus 20, which is equals to minus 12. Sending right side. So Vx term I am going to take it common into 1 divided by 10 plus 1 divided by 20 plus 1 divided by 30 plus 1 divided by 60 you are going to get. 60 is the LCM for this. So what is the value you are going to get? So the Vx value, Vx into 6 plus 3 plus 2 plus 1, which is equals to minus 12 you are going to get. Now 6 plus 3 is 9, 9 plus 2 is 11, 11 plus 1 is 12. So what you are going to get? Vx into 12 divided by 60, which is equals to minus 12 you are going to get. The value of Vx will be 12 ones, so you are going to get minus 60 volts. The value of Vx you are going to get minus 60 volts. The node voltage is minus 60 volts, right? So this Vx is minus 60 volts. Here you are having the ground potential. The current is flowing from bottom to top. So the current through 20 ohm resistor is flowing from 0 to top. That is Vx divided by, right? This is the actual current, right? Divided by 20. But look at the things, this is the opposite to I2 direction. This is opposite to I2 direction. Or say suppose if you are having confusion, I can define I2. How I2 is defined? I2 is the current that is flowing from Vx to 0 divided by the resistance value is 20. What is the value of Vx? You are going to get minus 60. the value of I2 will be minus 60 divided by 20, which is equals to minus 3 amperes, which is equals to minus 3 amperes. Which option? Option A is going to follow. If you are solving this option by considering 8 milli, if you are solving, then the value of Vx you are going to get it as how much? 20 into 60 divided by 12 you are going to get. So the value of Vx will be 100. The value of Vx will be minus 100 you are going to get. Now what is the current you are going to get? Minus 100 divided by 20, which is equals to minus 5 amperes. Is there any option something like minus 5 amperes? No, right? So what we are going to do is we are going to assume that the current source value is not 8 milliamperes, it is 8 milliamperes. 48th question, see, it is something like a trap question, something like this you can think. The number of flip-flops in order to count 0 to 1024. To count 1024 numbers, nothing but it is going to start from 0 to 1023. You are going to make use of 10 flip-flops. But what they are asking is you have to read 1025 elements. Nothing but you have to read from 0 to 1024. One extra element you are going to read. So that can be achieved with the help of using one more flip-flop, that is option C, 11 flip-flops you are going to use. 49th question, it's based on Norton's theorem. So what they are asking us to find is what is the Norton's equivalent value, what is the current and what is the resistance that is seen through this RL they are asking. First case, in order to find the Norton current, what we have to do is we have to remove the load and we have to provide a short circuit path to it. So and one more thing, what we are going to do is this 15 volt 6 kilo ohms, I am going to denote something like this. I am going to write the equivalent current source of it. If I am writing the equivalent current source, what I am going to get is 15 divided by 6 amperes. 15 divided by 6 milliamperes, or this is a 2.5 milliamperes. And then the resistance value need to be connected in, parallel, 6 kilo ohms. Then you will be having one more current source. This one more current source value is how much? 5 milliampere. Again you will be having 2 kilo ohms. Now you have provided the short circuit path for RL. Now what is this short circuit current? Or it is also referred as Norton current. Now you please think over in this way. This current will be flowing in this path only. It will not be flowing through the resistor. Why? Least path. Even this 5 milliampere is also flowing in this short circuit path only. Then what is the value of this short circuit current or Norton current? The value will be 5 milli plus 2.5 will be 7.5 milliampere. 7.5 milliampere. Option A is going to follow. If at all if you want to find the value of, if you want to find the Norton equivalent circuit, so what you are going to do is you have to remove the load. Right? So this Norton resistance, how you are going to find is, first thing, remove load. Then all the voltage source need to be treated as what? Short circuit. And all the current source need to be treated as what? Open circuit. So look at the things. Current source is there, I have treated it as open circuit. Then you will be having 6 kilo ohms. Then you will be having one more current source, open circuit. Then you will be having 2 kilo ohms. Now this is the terminal. I am going to take it as A and B. Now looking at this terminal, what is the resistance that is offered, referred as Norton resistance, or even Thevenin's resistance also is the same. Now what is the Norton resistance means you will be having the two resistors that are connected in parallel, 2 kilo and 6 kilo. What is the equivalent of it? 2 into 6 divided by 2 plus 6. So the Norton equivalent network is 3 by 2 or 1.5 kilo ohms. 1.5 kilo ohms, right? Option A is going to follow. Last question. Till now, if you have not liked the video, please give it a big thumbs up. Simple question they have asked. First question is also from HDL and the last question I have also chosen from HDL topic only. The full form of HDL is higher descriptive language, higher definition language, hardware description language, high descriptive language. So it is referred as what? Hardware descriptive language. If they would have given, instead of HDL, if they would have given VHDL, then it would be a good question. Very high speed integrated circuit hardware description language, right? So this is the like acronym of VHDL. If they would have specified very high speed hardware descriptive language, many of them would have opted. Very hardware descriptive language, many of them would have been opted. Very high speed integrated circuit hardware descriptive language is the correct option. So friends, already I have discussed JEE and AE paper of electricals. So if you have not watched the video, links are given in the description. Also, you can click on the I button. Now in this video, I have discussed from question number 1 to question number 50. In the next part of the video, we shall discuss from question number 51 to question number 100. If you have gone through the solution video and if you can able to understand and correlate with the things, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. All the best for your results. Thank you.